How's it going? I'm back. This is Key, and you're listening and watching Primitive. And today we're going to be continuing our series Built in Public with episode number 6 with the Comic Panel app. And today we have three main things to talk about and to do. The first one is to, these are actually out of order, but the first one is to look at Windsurf. I want to talk a little bit about what Windsurf is and show you my Windsurf setup. I also want to talk about SQL because it's a part of this project, a pretty significant part of the project, in fact. And then the last thing is I want to spend a little bit of time working on the Pixi.js integration, which will be just a small step to make our current app mirror the technology and the approach that we hope to achieve with the final design. So without further ado, I think we can go ahead and jump into our session today and go ahead and get started with coding. Yeah, let's go ahead and do it. Hey, how's it going? It's me. Okay, so the first thing that I want to do, and this is out of order for how I mentioned them, is I want to talk about SQL. So I have the immense pleasure of getting to tutor people. And one of the things that I've had a chance to tutor specifically about, one of the things I've had a chance to tutor people on and to teach for the past 2.5, 3 years is SQL. SQL is by far the most popular type of database. And as someone who is a web app developer, someone who makes web applications, websites, and even some desktop applications or native applications, SQL is very likely to be something that you're going to be working with. So I wanted to do just a quick review of SQL. And this is just a very high level explanation of the things that we talk about as being important in this conversation about SQL databases. So the main thing to know about SQL is that it is intended to store structured data. So the basic story goes that back in the day, before databases were invented, there was still science. And science is very heavily influenced by this activity of gathering structured data. As a scientist going out and observing nature, you tend to gather structured data. Think about, for example, the life sciences, right? Um, as a biologist, you might be discovering or organizing animals that you find in nature or plants you find in nature, right? Organisms. And in order to do this, you have a structured approach. So, for example, you may categorize and observe and record data about different types of dogs, right? And each dog that you are observing or cataloging or including in your research, each dog is an entity, and you might be making a comparison, right, between these different entities, or might be tracking them for various metrics. Anyways, the short version is that our idea of a structured database comes from the way that scientists historically gathered research data in structured tables. And so when we're talking about SQL, that's like a really handy way to remember exactly like how this is intended to work. So let's first talk about like what a database is and what it looks like. Let's go ahead and zoom in here. So this is like a really rough drawing of what SQL looks like with Postgres. Postgres runs a big server on your computer locally. Also, when you deploy Postgres, it will be ran in a server very likely as well. And this server for SQL allows for us to host any number of databases. And each of these databases can be thought of as correlating to one or more of your projects. So for the kinds of things that you'll be making as an individual developer, it's very likely that you may just have one database. Or if you have some more complicated use cases, you may have multiple databases that are of different sorts of databases. But for this example, we're only going to think about one type of database and different instances of that database per project. So in this first database here, you'll see that this is blue. And this database can in fact have many different tables within it. Okay, so databases are in part collections of tables. And you can have as few as one, and you can have hundreds, I suppose. You know, you can have some seemingly large number of tables if you would like. Okay, so databases hold multiple tables. Now, a table is meant to represent an entity, right? So all dogs can belong to the same table because dogs are of the same sort of entity, right? Dogs have, as you would say, related attributes between various dogs, right? And what differs between them may be the value of those attributes or the degree of those attributes, perhaps. But all dogs have similar or same attributes. For example, a dog will always have some degree of furriness. Some dogs are really furry, some dogs are less furry. Perhaps that is being tracked by an integer. You know, the higher the number, the more furry, the lower, the less furry. All dogs have a height. All dogs have a tail. That tail can be curly. That tail can be straight. That tail can be fuzzy. That tail can be not fuzzy, right? So when you think about all of the different attributes of dog, those attributes that dogs may have in common are not the same attributes as a computer, right? So if you have an entity of computerness, then that deserves its own table. And so what happens is the database becomes this collection of entities that each serve various types of records that are appropriate to it. Dog table is a collection of various types of dogs, and a computers table is a collection of various types of computers. And each of the records within each of these tables hold their own value for the attributes of that table. Okay, so here the table is the white part, and the red part is the attribute. Okay, so when you're thinking about databases, it's really important to make sure that you have like a clear distinction between the actual database portion itself and then the actual table portion. A lot of people get this mixed up here. Okay, and then the actual attributes. The attributes belong to the table. The tables belong to the database. Okay, so when we're talking about tables and attributes, sometimes you will hear people use some terms interchangeably. Sometimes you'll hear people use some terms interchangeably when we're talking about databases. The two that I often hear is table. A table is often called an entity. You're going to hear people use these two terms, and when they do, they very likely mean the same thing or something similar. The other term that you're likely to hear is attribute. An attribute is just a specific column on a table. If you think about a table as being column or data, then it looks like this, right? So each of these columns will have some sort of entry in them. And these entries are the rows. the columns, so this part right here, this part here, this part here, this part here, and this part here, these columns, these are the way that we can see the attributes as they relate to different rows of data. Okay? So the attributes are the columns. And if we were to bring this table or one of the records within the table into our code, then the attributes could also be known as properties. Let's go ahead and put a green box there. Okay, so by the time that we have this in our code, an attribute will be some sort of property that relates to an object or a map in some instances, okay? Otherwise known as a dictionary, okay? So attributes are like properties. Okay, so let's look at a really simple example. So this represents a table, just like what we were looking at before. Imagine that it's this table. This table is organized such that there are 5 different columns or attributes that define what a dog is in our world. There's the ID. We have an ID. We have a name. And we have a breed. We have friendliness. And we have age. Let me get my pen. I got it right here. So what this means is that every time we enter a new dog into the dogs table, that we are going to define each of these properties for that new dog. Sorry, just 1 second. Need to make sure that my drawing pen is working. There we go. So I can draw here. Oh, I think I'm sorry, just give me 1 second. I think my driver for my tablet is, needs to be restarted. Apologies for the technical difficulties, y'all. Oh, weird. Okay. Okay, I know what I need to do. I need to recalibrate my monitor. I am using the developer version of... Okay, that didn't work. Okay, cancel that. We'll just... Sorry for the awkwardness. I was trying to use my stylus pen, this thing right here, and apparently me being on the developer version of Mac OS, it's not working, so I'll just go where I left off. So, okay, so back what I was saying before, we have ID, we have name, we have the breed. We're going to have whether or not the dog is friendly, and then we're going to have an age. Okay, so age is going to be the property that is associated with an integer. Age is going to be an integer. And we actually forgot to put that here, so let's go ahead and get one. Let's do this right here. int. Okay, so we have an ID. Yeah. So we have an ID for the dog. We have a name. We have the breed. Whether or not the dog is friendly. And finally, an age. Now, for this table, there are these 5 attributes. And these 5 attributes must be described to varying degrees, but not always, for each dog that is entered into the dog's table. So, for example, let's go through each of these different attributes for a dog. So, the ID here is described by a set of properties. The first one is the type. What we're saying here is that the ID is going to be an integer. Usually and often IDs are numbers, numerical values. We're also saying that this is not allowed to be null, which is essentially a way to say that this property is required. Another thing here is that the ID must be unique. What we're saying here is that within this table, we cannot reuse whatever value is set for a dog that exists on that table. So if we already have an ID of 1, we cannot reuse the ID of 1. And then this last characteristic here is we say serialized. Serialized is just a shorthand way to say that we want each new dog to have a number that is incremented up from the previous. Okay, so the name is the next attribute here. And for the name, this is a little more simple. But what you can see here is that this is a type called varchar. In SQL land, for now, we'll just say that this is essentially just a string. It's a string that has a designated size, however. This is the maximum size of 80 characters. Okay? And then we say that this is required. Okay? So required and not null are the same thing. Sometimes when we're doing notation, you might see someone just write required, but the real way that you'll write that out in SQL is actually not null. Okay. So breed is also varchar because it's a string. Friendliness here, for me at least, is going to be a Boolean, yes or no, and then age will be an integer because it is a number. So out of all of these, the one that typically ends up being the most important is the ID. Because an ID, in this context for us, it is what's called a primary key. Primary key means that this is the primary identifier that we use to distinguish one record from the next, one entry from the next. So that if we have 2 dogs that for whatever reason have the same name and are of the same breed, friendliness, and age, but they're 2 distinct different dogs, at least the ID between them will be unique. Okay, so IDs are almost always unique, typically numerical, and they are the main way that we can recognize and target and pinpoint unique records within our table. Okay, so that is just a close, simple look at actual tables. Okay, so how do we interact with the database? That's probably the next question. How we interact with the database is really important. The database is typically something that we will interact with through some type of interface or driver. And here are three that come to mind for me, although there may be other ways. So first, we have what's called a graphical user interface. A graphical user interface is a visual client that allows us to work with our database, and it gives us a way to see also the contents of the database in something that more or less looks like a spreadsheet. Let's open up Postico just for an example. So this is Postico. So let's open up Postico for an example. So this is Postico, which is the graphic user interface for Postgres. This is version 1.5, so this is an older version, but this will do the job. So we'll connect, and when we connect, we can go and look at the databases that we have available. And if we look in here, we see that there is MyDog app. When we open up MyDog app, we can see that there's one table, and this table has attributes of ID, name, when we open up our database, we see that we have when we open up Postico, we can see that our Postgres server has a database called MyDog app. And within this specific database, there's one table called dogs. And this table here has four different columns or attributes, and that is for ID, name, is friendly, and age. And each of the rows, the horizontal portions here, represent individual dogs that exist in this table. These are the entities, so to speak. Now, how we get this information in here can happen through this graphic user interface. So for example, we can actually write SQL directly within this application. You can see here that there are many different scripts, and they each do their own thing. We have a script here that defines and creates the table. Look at how the verbiage right here, is very similar to what you were seeing in the drawing that we were looking at before. The verbiage right here is very similar. We've seen this before. Does this look similar? Yeah, they're basically the same thing. So everything we described right here is the same as what we've described here. Now we can take this a couple steps further. We have the ability to make insertions. Let's say that you have this database, but you want to have some data. Let's say you made this database, but you want to have some actual data to play around with. So here you can see we have some insertions, and these insertions are to add new dogs. So here's my lovely dog Ogu, his name, his friendliness, and his age. And we also have another script here that allows us to add multiple dogs all at once. Now, you might be noticing here that we are not providing all the values. This isn't like an SQL tutorial, but one thing I will say is that when you have a serialized value that is also your primary key, you will typically see that it is excluded from insertion statements because the database will handle populating those values on our behalf. So you can see here that in my entries within this table, there are IDs here, but these were actually defined by the database. I did not have to define these. It tracks that for us. Okay, so the last two things I'll show you, or the last thing I'll show you here is that we can also do selections. This allows us to retrieve data from our database. So anything that is stored in a table, we can write a script to narrow down to it, one or more things at a time, in fact. And we'll be doing a ton of this when we start to incorporate SQL and specifically SQLite within our project. So there are different forms of SQL. Postgres is one. We're actually going to be using a different form of SQL called SQLite, but that's neither here nor there. Okay, so that is an example of a graphic user interface, and that gives you basically an app that allows you to click around and to move through your database using a series of menus and windows and graphics, which is oftentimes much easier for people who are visually inclined. But there are two more ways that will probably come up in your coding journey. The second way is programmatic access, and this happens through a driver. Now, if you're someone who's following the stream, it's very likely that you're aware of some things within the world of coding, such as dependencies in libraries within applications. So what this basically means is if you have a server or something in your code that is programmed to connect with a database, it's very likely being enabled by a driver or a specific set of code that is designed for that programming language to interface with the database as it is running. Okay, so this is something that is immensely important and immensely powerful to enable your database to connect with your data. This is really important and powerful for allowing your server to connect with your database. And then we have command line interfaces. A command line interface is essentially a tool that allows you to make different manipulations of your database using your terminal. So imagine how you write different terminal commands. Well, you can do all of this SQL scripting, the same SQL scripting we did here. You could essentially do that within your terminal to control and manipulate your database as well. For beginners, I highly recommend the graphic user interface approach. And then as you start coding, of course, you'll need to know the programmatic approach as well. You can get by as a developer without being very good at the command line interface. However, there are situations where it is extremely useful and important, such as if you're writing scripts and automations meant to target the terminal. Or things that might have to do with like Docker or VMs, but that's not going to be a part of our channel. Okay, so these are the three different tools that you can use to connect with your database. And these all are to facilitate CRUD. CRUD is the 4 basic operations that we'll be doing to our server that will ultimately a lot of times end up in some type of database behavior. So the C stands for create, the R stands for read, U stands for update, D stands for delete. Creating means inserting something into the database. Creating means inserting something Creating means inserting something into the database. Reading means selecting something from the database. Updating means altering something in the database. And delete, of course, means to remove a record from the database. These 4 different operations are meant to be ways of describing how we deal with things like records and tables that exist in our database. Okay, so that's pretty much just like a brief. I guess the only last thing I'll say, and this is a question that recently came up in a tutoring session that I did with one of my clients, is When you were dealing with tables, people oftentimes will have a sort of like style for how they name things, and this helps distinguish so that we can easily read and know what things are. You'll see that oftentimes people will use snake case for the names of tables, especially if you have compound words. And you'll see column names are oftentimes done in camel case as opposed to snake case. Now, this will vary. In some places, this is reverse. It's ultimately a matter of the coding development culture where you are, or whatever practices you've developed yourself. The most important thing is that you develop a convention. This becomes really important for sight reading. When you're reading through code really quickly or trying to refresh yourself on what something is or is meant to do, having consistency in your naming conventions can be really, really helpful for your intuition, your code smell. So just take that as a grain of salt and make of that what you will. So that was just a little brief run through about SQL. And in our project, we'll be using a different form of SQL. We'll be using SQLite. Let's see, I got it right here. So for our project, we're going to be using SQLite. This is actually a different form of SQL. It has the same syntax for actually manipulating and interacting, but the underlying way that the data is being stored and accessed is different. So similar type of interface, different strategy. Okay. So right now within our project, we can go ahead and open our recent database. You can see here we have one table called messages, and this table doesn't have much on it right now. I think that there is a way that we can view this data. Browse table. So you can see here, these are all the different entries that are being stored in this messages. This is just a placeholder for us right now, but we'll come back to this and we'll refine this database, and we'll be able to create SQL that is being executed by our server to be sent to our database to do things. Or we could also use this interface here for it as well. Okay, so I think we can go ahead and move to our second topic, and let's talk about Windsurf. But let's go ahead and take a quick break. I'll be right back. Okay, we are back and we're ready to go. Thanks for joining us. We're going to go ahead and talk about Windsurf. Let's get into it. Okay, so this is Windsurf. And at the moment, Windsurf is literally my favorite way to write code. It's my favorite text editor. And the gag is that it's basically just VS Code. VS Code for AI enthusiasts. And the only real significant thing that I like about it that makes it different from VS Code is the fact that it has its own built-in support for an AI agent. Now, this AI agent is not like anything like radically different than what you're going to find with Copilot. It's very similar to the experience that you're probably having if you use Cursor. Um, I've used Copilot and I've used some other tools. And I'll say that if you like what you like and it works, you do not need to use Windsurf. I just happen to like Windsurf because it's like the thing that I started out with. And also, Windsurf has done a good job of sort of keeping up with the pace of things. Now, when you're working in Windsurf, you have the ability to access all the normal tools that you have access to in VS Code. There are a couple of differences, though. One difference is that when you use the extension store, there is actually a different marketplace that is not the same exact marketplace that you use with VS Code. The marketplace is essentially the way that you can see all the different available extensions and which ones are visible. And depending on your marketplace settings, different extensions may or may not be available. Now, this has only ever come up a couple times when I was developing in PHP. There were some extensions that I couldn't find with the Windsurf browser's default marketplace. And when I was developing in Rust, there were some extensions like the Rust Analyzer that were not available. Oh, and then also I was developing in Dr. Racket. What language was that? Why did I forget the name of this language? Oh my gosh, the computer scientists of the past are rolling in their graves right now. Um, Lisp. Yes, Doctor. Yes, Lisp. When I was developing in Lisp, I also ran into some issues finding some extensions. So that is just to say that it's possible to work around it, but what you're going to have to do is modify the marketplace that your IDE is set to. Okay, so I'm not going to get into like the details of how to do that, but you can go online and you can find alternate marketplaces to use for your extensions, and then you just use the one that you need to get the thing you need, and just remember to change it when you need to. Okay, so that's one thing that's different with Windsurf. Another thing that's different with Windsurf is Cascade. And to me, Cascade is like really the main feature that draws me in this corner. It makes up for all the other inconveniences with the extensions. So Cascade is essentially a tool that allows you to leverage existing large language models in order to have an agent that performs code, type, behaviors, and actions within your repository. So here I have the Comic App repository open, and I have Cascade, which you can open by clicking right here to toggle Cascade. Now you can see within this interface, I have the ability to initialize a new chat session. I have the ability to toggle the modes so that I'm in write mode or in chat mode right here. I have the ability to change the model that I'm using for my AI. As you can see, I have it set to Claude Sonnet 4. Now, ChatGPT 5 is also available here as well. I'm not going to get into that, but it is available in Windsurf. So try it out if you can. Here I have some options. These are things that can help me with context, such as planning mode, the ability to incorporate audio. I can speak, and then also the ability to use images in order to have them considered whenever you're providing feedback to AI. Beyond that, we have the ability to connect MCP servers. So if you have MCP servers that help you, like Context 7 or the GitHub MCP server, whatever you have, there's a way to set that up. You can also preview your app, and there's a built-in browser that we're probably not going to use here, but I love to use the built-in browser because it allows you to easily send log messages and screenshots and elements back to Windsurf directly in order for you to use them in your upcoming prompts. And it's a really good feedback loop. And that really only works at the moment with web apps. And then the last thing here that you'll notice is that we have a section devoted to previous conversations. Sometimes Cascade does get a little bit slow when you get really, really long conversations, and coming back here to reopen a previous conversation somehow cleans it up. I think there might be some compression that happens. So I don't personally use like all of the ins and outs of every single feature. I'm constantly learning, but the main thing about Cascade is to know that when you start a chat session here, what you're going to be doing is you're talking to your AI agent, which you can pick the model that it uses. And essentially, you're targeting the file system of the repository that you're working inside of in order to ask AI to make changes. And that can be things like writing code. You can see here I also have documentation that I use it to help me write about the code, scripts, organizing, auditing. I even use it to help me with code review as well. And I'll talk a little bit about how I antagonistically will even use chat. I'll even antagonistically use some version of LLM with Cascade in tandem with Gemini CLI in an antagonistic relationship in order to work on some of my tasks. So essentially, I'll have Cascade maybe execute on some things, and then I'll have Gemini CLI review and say, hey, check out this work. Let me know if it meets our requirements and provide your feedback on how we can improve this. And then I'll take the feedback from Gemini and I'll feed it back into Cascade. So you can kind of run multiple agents or chat sessions within the same repo. And that is possible because you also have access to a terminal. So you can see here we have Cascade and we also have these terminals. Now for this setup, am not going to use the terminal that is built into Windsurf. Instead, I'm going to use my warp terminal off to the side. And you can see here I have my Gemini session going on the very far left, and then I have Windsurf and Cascade running. And Cascade happens to be running Claude. I could also run Gemini, but I like running a more advanced model because when you subscribe to Windsurf, and which only costs about $10 for the basic package, you get quite a bit of token usage. I personally have not ran out. It's very hard for me to run out. So they're very generous with how many tokens you get for that $10 a month. And you can pay for more if you want a more premium or professional quality or quantity. Okay, so that's the basic setup. And I'm going to continue to talk about Windsurf as we do this and try to give some tips and tricks as I go. But let's go ahead and jump into our project. So where we left off last time is we had a very basic app running, and let's go ahead and try to get that running. I haven't looked at this since the last time we were coding, so I have to remind myself how this even works. So let's go ahead and split our terminal, and let's go ahead and use, we can use this terminal here to get our app running. So let's go to our scripts here, And I think we need to run, let's just run front end dev. Oh, we need to run dev. Let's run dev. So run dev. I've been working on my website for, I don't know, the past like week and some odd days. I don't know how long I've been working on it, but I've been working on a new update, which I want to give you a sneak peek so bad. Let me just give you the world's quickest sneak peek. This is the new website. It's not completely finished, but this is like an update to what I currently have, which will make it more robust and useful for you all. But I've been working on that, so it's been like literally whatever amount of time since my last stream. That's how long it's been since I touched this app. So, and the scripts and the repo for my app is like way more complicated than this. Like way more complicated. Okay, so this is going to take just a second because we're building the application. And also when we build this application, it's going to run the dev server for Vite as well. So we'll get hot reloading on both the server and the front end. But it just takes a minute to build. And I think we only need to have that one terminal, if I'm not mistaken. Yes, okay. Good. Okay, so let's go and look at our docs. And last time we were working, we had this, we'll close Cascade for now. Last time we were working, we had this document here. This is basically like the document for our sprint, which is, I guess it has ended up being like 2 or 3 weeks here. But the next thing we're going to work on is we're going to refactor the front end. Right now, it's like a draggable feature that allows you to drag something, store its location, and its content or its message in the database. We're going to change that so that it works using Solid Pixi, which is a solid implementation of Pixi.js. So this whole thing right here, this thing that moves around, we're going to basically remake this, but we're going to do it with Pixi.js instead of, I think this is HTML canvas. Also, it is very laggy. Not really sure why. We could probably inspect. There's a performance tab. It should be. I guess maybe. Okay, maybe that's something solid, or maybe that's something Tauri doesn't have. I know when we're working in the browser and you inspect, there's a performance tab that gives you some relatively useful information about performance. That does not appear to exist here. So we're going to have to find some way eventually to monitor performance, or at least to do some type of profiling to determine memory utilization. We could probably do that with Rust, but finding a way to do it with the actual UI will be very important for us. Okay, yep, that's going to be a learning area. But anyways, this is our app as it is right now. Okay, so let's go and look at our code. Let's look at this here first, then we'll look at our code. So we're going to integrate Pixi.js, and there is an implementation of Pixi.js for SolidJS called Solid Pixi, and we'll use it with version 8 of Pixi. What I'll do is I'll tell Gemini here, and I'll say, please read current.md, stand by for further directions. I'm going to give the same instructions to Cascade. I'll say this. I'll also say here in this prompt, I'll say please read current MD, stand by for further directions. Also, please review our Gemini.md context to discover any useful standards that you may need to do this work. Okay, so this is going to do two things. It's going to allow Gemini to prime itself with information about the upcoming work that we need to do based on what we've already done in this document as a whole. And then it's also going to review our customized Gemini context files in order to understand what our best practices and expectations are as a whole for this repo. That way, when it's coding, it's going to be able to do it in a way that respects what we're actually asking it to do. So I can see here that I've ran out of my Gemini Pro utilization. So we'll just go ahead and use the Flash model. We'll give the same command again. While it's running that, I'll go ahead and give the same command to Cascade. And I'll say, as we code, I will ask you to continue to work in a modular way that aligns with our best practices and previous structure and architecture. Work with the future goals in mind. Now, the whole context window for Cascade is not the same exactly as we have for Gemini. Gemini has its own Gemini Markdown files that it uses. Cascade has its own system for how it maintains memory across sessions and also retains its understanding of our own preferences as we work with it. And that's called memories. And memories within Cascade can be accessed and manipulated. So if you go to, so memories within Cascade can be accessed and manipulated. If you go to customizations, which is the tab right here, you can see that there's a tab for memories, and these memories can be searched, and you can also give it more information if you want as well. The way that you add memories is in the chat session, you explicitly tell it to remember something. So it'll oftentimes take a collection of things you tell it to remember, and it'll put them all together. And then also you can edit these if you want to as well. Okay, so I usually, as things come up, I'll say, hey, in the future, please remember this detail, and it'll make a new memory based on that. Okay, so I do not want to have both of these working on my repo at the same time, but it is okay for me to go back and forth. I'll oftentimes have Gemini do something, and then I'll have Cascade check. Sometimes I'll have Cascade do something, and then I'll have Gemini check. Either one is fine. Both have their strengths, and depending on the day of the week, one might be better than the other, as it seems to always change with these LLMs. Okay, so I'm going to be integrating Pixi.js, which is going to result in a draggable element rendered within it, and this will be replacing the current canvas style situation I have going on. In fact, I forget how I have this. Let's go ahead and jump into our code here. And let's go to our source folder, which is for the front end. And let's go here, app.tsx. We have just one component, no subcomponents, and everything is in this one file. So if we go here, excuse me. Let's open up Tauri. Get these two side by side. Hey, Theo. Thanks for stopping by. Thanks for stopping by the channel. I appreciate you coming over. And thanks for the like. I always appreciate those. I like you back. Okay, so I think we can find the text if we are clever enough. So we have an inspector that we can use. And let's see. One thing I'm going to have it do that I'm not doing right now is maintain IDs. Now, right now, this isn't as big of a problem because I can obviously see that we have a main component here. And this main component is pretty much this whole thing, this whole blue section. But in the future, I want to have IDs on things because it's going to make it a lot easier for me to go back and forth. It's also going to help me understand exactly what I'm manipulating when I'm trying to debug and stuff. So essentially, we're going to take this entire div section right here, and we're going to replace it with a canvas. Okay, so let's be smart about this. In fact, let's open up our lovely friend Freeform. So what I want for my app is I want to be really smart about how I provide the canvas space for this, because I want to do this in a way. I want to do this in a way that allows me to easily start to work into my actual idea instead of just putting something in that's going to be like completely obliterated as I work. So let's do a little bit of planning just to kind of see the essence of what our app should look like. And I already know what this needs to look like because this is a remake of an existing thing. So what I want, if this was the full screen, is I want to have 3 distinct sections for this app. And let's give these 3 sections their own unique color. So we'll make this first one, or this one here, pink, and we'll make this one cyan, and we'll make this one, I think black is probably fine. Okay, so in our app, this blue section here, this is going to represent our options and controls for our app. And then this pink section here is going to represent our navigation for our pages and panels. So options, menus, and tools. And then this will represent our page and collection navigator. And then this middle section of our app is going to represent the canvas area. Okay, so within this canvas area, the goal is for me to have some type of floating element which eventually will represent a page that I can move around. Imagine like this is your favorite design software. I can move around my page or whatever my canvas is inside of this area, but it cannot pass the boundary that it's within. Okay, let's just put a word in here. Excuse me. And let's make that bold, and let's make the text larger. Okay, so this page essentially cannot go beyond the border. Now, I'm eventually going to probably have this page fixed in the center and then allow it to expand in order to take up as much of this space as possible. That's kind of going to be a goal for me. But for now, what I want to do is make it where this page can exist somewhere within this area here, okay? And I don't need to do anything for the options and menus or for the page collection navigator, except to make sure that those spaces exist and that the spatial relationship between these three sections is defined so that I have a place to put my floating page. Okay, so let's go ahead and lay out just like a really simple skeleton for this general layout concept. And I think the first thing is that this is probably going to mean that our application window needs to be at some type of minimum size for what we're trying to do. Considering that our application might also have some ability to scale. So let's quickly go to our Tauri source. I think there is a way that we can control the actual window size. And I think there's also a way that we can fix the window size to some type of minimum. Let's see what Gemini has to say. It might be able to help us. So actually, let's use Cascade. Let's keep it simple. I don't want to have so many windows on my computer right now. We'll come back to Gemini when I need it. So I'll say in the Tauri config.json file, is there a way to make the app window minimum size defined? Let's see what it has to say. I'm pretty sure there is. I just don't know it off the top of my head. What I want to say as well is I want the minimum to be in the proportions of, let's say, actually, I don't want to impose proportions. Let's just say I want the minimum height to be I think the height right now is actually pretty good. That's pretty good. I think the minimum width should be 1,000 now. And I don't expect that anyone's ever going to want to use my app. At least as far as how I'm designing it right now, I don't suspect that they will want to use my app at any smaller size. Since this is meant to be a desktop comic book medium style, helper app, I don't think that it's going to be very useful to run this like on a phone or anything. So I'm not going to be thinking about that right now. So let's go ahead and get our application running again. I think we stopped it. Yeah, we broke it, so we got to run it again. Okay, so something that we got to do too is we got to also make sure that this matches. Okay, so it didn't break. I thought this would break, but we got to make sure that the minimum width also matches. the opening width and stuff. So it'll never be able to go smaller than the size that it is basically launched at. Okay. So as long as our app details look good, and honestly, I would not be opposed to launching this app as a full screen app. I think it might be a little bit overkill. Um, yeah, I don't know. I feel weird about enforcing that, but I think this is fine for now. So let's go ahead and open up our app here. This is going to completely destroy our usage of the oh, you know what? We can actually save some of this. Okay, so I think the first thing we need to do is we need to break up this app, and we could either break it up or we can just assume that maybe some of this stuff won't be useful. If I was going to continue to use this messaging stuff and the draggable feature as it is now, then maybe I would want to keep some of this stuff and put it in its own file or sort of break it up into like subcomponents. But I think what I'm going to do actually is I'm just going to gut this whole thing out, honestly. I don't need any of this stuff now. I'm going to get rid of this stuff here. We don't need any of these functions. Yeah, we don't need any of this stuff. And now let's just do a comment here. We'll say we have the 3 columns, and we'll say that this first one is menu or tools column. And oops, we'll say that we have a canvas area. Let's put this in a span. We'll do the same thing for the canvas, and we'll also make just one more section down here, and then this will be for not status bar. This will be for the navigation. Okay, so this is kind of like a little bit of a skeleton. What I'm going to do is I'm going to tell AI here in app.tsx, I have a simple skeleton. I would like you to set up set this up as the main layout, which will persist across the use of the app. And oh, I also forgot, I got to get rid of these functions on the inside here. We actually don't really need any of this stuff. This was all just to kind of like, make sure that the basics of SolidJS was going to work for our use case, but I think we're confident about that now. So we'll get rid of all this extra stuff. We'll gut this out, and we'll just redo all of this stuff here. We don't need this interface. And we can clean up the comments here as well. Okay, so this will all end up being the layout at some point. And then if we want to, we can introduce some like other wrappers or whatever we want to in the future, but we don't have to think about all that right now. We forgot our div here. Okay, so let's go ahead and format this. And we're good on that. Okay, so once again, I'm not thinking about like whether or not this is all perfect. I'm giving AI something to work with is kind of the goal here. Okay, so I'd like you to set up the main layout, which will persist across the use of this app. This is a creative design app for comics, as you are aware. And something that we did before is we had a project scope document. So I could even tell it to read the project scope document here. So please read the scope document to get the big picture, and then use the skeleton to lay out the boundaries of the three main UI sections. And I'm going to tell it, I'm not going to use the name of any of my inspiration apps necessarily, but what I can do is, since I did that drawing in freeform, a little simple diagram here, I can just take this image here. It's going to save it to my desktop. And I'm going to go to Windsurf. And give me just 1 second. I'll load it up. Okay, so I have the image loaded up that we made in freeform. That image is super helpful. When you're using AI to vibe code or make things, having some type of sketch is super helpful, especially if you're not really good at explaining exactly what you want it to do. Having an image or a little doodle or something, or even an actual wireframe, is super useful. So this is going to take a moment to analyze the image I gave it. It's also going to look at the actual scope project document, and then it's going to follow my instructions. So this is going to be essentially lifted from the previous prototype that we already made for our application. So let's see what it does. Now, one thing I will say is that it seems like Cascade is so much slower. Oh, it looks like it might be having some connection speed issues. Not sure. Weird. Okay, so let's see. Let's just check the work, I guess. So whenever you're using Windsurf, something it's going to do for you is it's going to indicate the new things and the changes. The green sections are the changes. The red sections are the things that are being omitted or deleted based on those changes. So if I go ahead and accept this, I can see that it's attempted at least to make a new interface for us. And now it went a little overboard. It went really overboard. But we can basically give it some instructions to refine this. This is not what I wanted, but this is close. Okay, I really just kind of wanted these to be empty sections, but this is not too bad. Actually, this is I think the fact that it read the document I gave it is probably what makes this close enough for the time being. Okay, so what I'll do is I'm going to tell it to make the 3 sections empty. So let's simplify and make the 3 sections empty. I know what I want. So I don't, and also too, I don't want the UI to outpace the actual APIs and stuff that I have prepared, because then it's going to get really messy. And I want this to actually be a long-lived application, or a relatively long-lived one. So I don't want to like just build a bunch of stuff and get it really, really messy. Otherwise, I'm going to have a heartache. And as you can see here, this is already almost 200 lines of code. And a lot of it is not code that I necessarily want, but I don't want to continue working in that way, because it's going to get really, really gross. Okay, so something I'm going to have it do is I'm going to have it establish a place to store style constants early. Style constants are basically reusable collections of style that you can use and share, which will allow you macro level control of your UI. So I'm going to say, hey, within the source, or within the front end source directory, I want to create a central theme, and also a directory to store style constants used across the front end. So it's going to do that. We're using Tailwind, so it's going to configure that based on Tailwind for me. Let's see if it remembers that I'm using Tailwind. I'd be concerned if it didn't. Now, right now, our Cascade is running in planning mode. This for us is overkill. I'm going to turn it off, but it's going to continue using planning mode until it finishes up this set of executions. But it's going to make us a theme file here, and this will be like kind of a time saver. You see how we're doing like all this inline styling? As much as I do like the ability to stack these with Tailwind, this becomes really, really, really hard to keep track of. And these could also become quite massive as well. So by having a set place to put our styles, now I don't necessarily want to keep all these styles. These might not be super useful for me. Let's see. But I will at least edit these and manipulate this as we go. And I can see here that these are some basic things that I might care about. Okay, so it has a set of constants as well. Now, something I do need it to do is I need to let it know that these need to be specifically okay, this needs to be specifically oriented for Tailwind. I'm actually going to go back. So one of the things you can do, a lot of times when you're working with Cascade, when you're working in some area that you might not be familiar with, you might give it a prompt and then it might make a wrong, assumption about what you want it to do. If you go to your previous prompts, you can click revert, and it'll basically undo everything that it did since you gave it that prompt, including if it made files or any changes. So I'm going to basically reissue my command and say, please use or do this with Tailwind in mind, as it is our primary styling tool for this repo. And let's give it another shot. Okay, so it's going to make a new theme. It's going to use our style folder, hopefully. Let's see what it did this time. Okay, so this theme here, let's see. Okay, so what's going to happen, I think what it's going to do is these themes here should result in something that is composable and then also injectable into a Tailwind config file. And within these constants and themes here, it's also going to determine how our layout is composed as well. And you can see here that the way this will work is that we are basically using the combination of constants and composing them with classes from Tailwind in order to make this essentially dynamic styling, because we're passing variables that are being templatized with the classes from Tailwind. Now, I don't know about all this animation stuff. We may eventually use it later on, but for now, it's not the most interesting or useful part of this for us. Let's see what it's complaining. It's saying it's never read. Now, one thing I like to do with Cascade is be lazy. But aside from that, there's a problems tab here. If you click the problems tab, it'll show you things that are from your linter. Now, a lot of times you can simply right click and then fix all the supported violations in the document. Sometimes you cannot automatically do that. So in this case, I know that I can just fix these myself. Okay, so let's reopen up our linter and see if those issues have disappeared. It looks like we may still have some here. Now, if you're ever in the position where you're like, I don't know how to fix this, or I'm not sure, if you look at the arrow here, this collapsible arrow shows you how these are grouped together. So all these are under the file index.ts. If you click send to Cascade, you'll see that it pops up down here in the chat input box. And you can simply say, please fix this. Now, while that does its thing, we can go and check out the rest of this README. Now, one thing I think that we probably want to do is I'm going to ask it, do we need to have some type of Tailwind config file? Tailwind config is what will allow us to have things like downloadable fonts and typography and stuff like that. It allows us to extend the behavior of Tailwind. And, oh, I already have one. I might have overlooked it. Where is it at? Oh, it's in the root level. Okay, perfect. So this Tailwind file here will allow us to set our theme. And this Tailwind theme is going to be like at the highest level of our app. It's going to allow us to reuse things very easily. So I'm going to give it some more refined instructions. Oh, in fact, it's already done it for us. So it's essentially taken those constants, the theme elements rather, and it's put those in that Tailwind config. So I don't think we need this theme.ts anymore. Give me a little bit here. Okay, we're back. Just powering through a night full of technical difficulties. So the progress that I made when I was on my little break, which wasn't really a break, is I've decided that instead of utilizing um, the constants file that I had to store these widths. These widths are actually really just pertinent to this specific layout of the main page. So what I'm doing right now is having it refactor and store widths inside of here in this constants file for main page, and then we'll just consume these as imports inside of the three places here. So the column, the left column, the right column, and the center column, essentially. So you can see here we have this width. And these are right now very impractical. So we'll find some more reasonable sizes for these. I don't actually know what a good width is. So I'm kind of eyeballing it here. 10 is let's do 20 and 20. Okay, so it'll end up looking something like this. And these will probably change. And also, I'll probably also make it where they're collapsible as well, because you may not want to see the tools or the navigation at some point in the future. I think actually 15 might be good for now. Okay, so then we can go to our tailwind config, and we don't need this. Yeah, we don't need that. And let's see here. Some of this stuff here might not be needed later on, but it's fine. We'll leave it for now. Okay, styling, direct mode. Okay. Okay, so we have like a basic layout here. This isn't like beautiful or finished or anything, but our next goal is we want to, actually we can do this before we leave. We need to basically use this center column, and we need to add to it our actual Pixi canvas. So I'm just going to add like a placeholder. So I'll say, can you put a placeholder Pixi.js canvas inside of the center column, inside of, let's just take the path for here and put a spinning star animation. Keep it simple. Red background, white star. It should fill the entire area. Okay, so let's see what it does. And if I can get that part working, then I am fairly confident that I can get the rest of the app up and working again with the actual element that has its like relative position XY coordinates saved in the database. So so it's going to check here to see what we have for Pixi. We have Pixi as well as the Pixi Solid stuff as well. Well, first of all, stop there. Hold on. It's trying to use npm. We are bunsters, but oh, we did not get Pixi installed here. So what I'm going to do is I'm going to have it read the current.md document to learn about our approach, to learn about how Actually, no, I'm not going to have it read it because it's gonna go on a tangent and try to do everything. So I'm just going to go and manually get those details. So we need solid Pixi, and we also need Pixi.js. So install solid Pixi and also Pixi.js. I want to use V8 to accomplish this. Read the install guides and set up properly first. You probably hear some beeping. I put some food in the microwave. It's my incentive to actually get off my bum and go eat. But of course, I've been drawn into another small task here, so we'll let it do its thing. While it's doing that, I just remembered I need to get the MCP server updated. So I have one. I have GitHub, and I have context 7. MCP. Oh, I forget how to set up MCP with this. MCP Gemini. Not MCP. Context 7. I forgot to set that up for Gemini. Let's see if there's instructions here. Gemini CLI. Okay, so I got to do this. I'll do this off screen. I don't know what MCP server I was using beforehand. Oh, this is... Yeah, I don't know what I was using before. But we'll fix this, I guess. I don't know what SSE stands for. Okay, so that is saved. So it looks like it is ready and it's working. Okay, cool. We use Bun, and also you have access to MCP. I'm a Bunster. I like using Bun. I just find that I guess AI must be very heavily trained on NPM. It is a constant uphill battle. Okay, so we're installing SolidJS, Pixi. I thought SolidJS was already installed. It did it anyways, okay. Oh, it's not finding the MCP. That is so disappointing. it stopped. I don't know why it stopped. Maybe because I wasn't using it. So it says right here in this output that it's running. Okay. Oh, what I meant was context. Context 7. Not 8, context 8. Context 8 is better than context 7. It can get documentation from the future. Okay, I don't know. I tried. I tried my best. I'm going to have to maybe find a tutorial or something. Dev server is running. Just continue. The only thing that that sometimes can be frustrating with doing Tauri development is that it doesn't necessarily it doesn't necessarily have as easy of a workflow between like just working on stuff and then informing Cascade about what's going on. And also, I don't think it did the Pixi integration, did it? Oh, it did do it. Okay. And is there a bug? I think there might be a bug somewhere. Import binding stage not found. Importing binding name stage not found. I don't know where that is. Here. Okay, we're getting some errors. Let's go ahead and check our problems tab, and we'll send this to Cascade. This is a ClickFest. And what was it trying to show us here? Was it trying to show us? Okay, yes, there's clearly some things that are broken here. Okay, I promise I will not start any more stuff when this is done. I'm going to be focused on leaving. Gosh, it's really struggling tonight. I noticed like yesterday and today, it seems like something with Claude has been weird. Um, also, I don't think it's understanding what to do with Pixi.js. I think Pixi.js is not meant to be used the way it's trying to, or solid Pixi. I'm just gonna look off screen here. Okay, so solid Pixi stage has no export member called. That's weird because I'm seeing it here on their website. Did I do bun add already? Let me. Okay. We kind of need this to work too. This part. I mean, this is better to figure out now. It's trying to like look through the actual source code of the dependency though, which is really odd to me. Okay. What version of this are we using? Pixi.js and SolidJS. Oh, okay. So oh, interesting. The exports are default exports instead of names. Exports, interesting. Okay. I'm looking at the website right now, and I'm not sure why there's this discrepancy here in the way that this is looking in the actual official website. Okay, so let's just see. Okay, and let's inspect. Planning on seeing some errors here. Okay, so we can look at this in our browser since it's just a UI thing, and we can go ahead and send screenshot, and we'll send log to Cascade, and we'll say don't run dev server, I got that part. We might want to set up something like Storybook. I don't know if there's a Storybook for SolidJS. That's something worth looking into. Because it might be easier to do some of this development if we have Storybook, because then we won't need to run the full application and it'll be just a lot faster. So there is a Storybook for SolidJS, and it looks to be in beta. Ugh, this is kind of convincing me that maybe I should just use React while I'm ahead. Nope, this is not working. Okay, I might have to end it off on this really weird note, which, as much as I don't want, that's just kind of where we are here. Let's just send this last message here. I'm considering that maybe I should just go ahead and switch the front end to use React. Initially, when I decided to use Solid, I was thinking about the performance benefits, but I think the biggest performance implications in my application are going to be in the whole part of this app that is running with WebGL or WebGPU and Pixi. I don't think that I'm going to have as much of an issue with UI stuff running in React because that stuff will be fairly simple. There's not going to be like a whole lot of nodes for that. So I'm kind of rethinking using SolidJS, and I think while I'm ahead, it might be worth my time to refactor, and that wouldn't be too much work because these TSX files will still be usable. Um, the only thing is that Beat will be building React instead of SolidJS. Let's see. So it's re-rendering this. Oh, there we go. Oh, look at that. It's working. It's working. I don't know what made the difference. I'll have to read through this. Okay. But it is working. Okay, so that is a relief. Because I really did not want to refactor. There's an error here, but that's fine. Min height. I think that's what we meant. Sure. So this is getting close. So by the time our app is like done, it's going to look something closer to this. And then all of our canvas and comic stuff will be in the middle section. Okay, so that is a surprising end to what has been a tumultuous night of trying to code. Also, it's also morning at this point, so it is no longer night. That's how long we've been doing this stream. So, anyways, we worked through technical issues. We worked through a computer restart. We worked through me not having the volume or the microphone on appropriately, but we did get a good little segment at the beginning about SQL and about Windsurf, and so at least I'll be able to make some content off of that. Unless that also too is broken, but that's just how it goes. I'm gonna say this before I get off here. I think a big lesson that I not only want to convey, but also am learning as I do this whole channel, this whole business is like things will come up. There's no way around it. And when you set your heart and your mind on something, what you're setting yourself up for is to just continue, just keep doing it, and just expect that if you give up on obstacles, you will not be successful. But if you don't give up, you might be successful, and more than likely you will find success in some way, shape, or form. So I'm going to stick with that, and I'm just going to take tonight with in grace and stride, and I'm going to commit this because we did get a decent amount of work done. We basically redid our whole layout system here. We actually have a hierarchical modular layout system, which is quite a feat, even though this was a weird night. I would say that this is a success, and thank you for coming by the stream. I'm going to hop off of here, and then I'll be back on the stream to continue working on this. Let's say I'll try to do something tomorrow. I'll try to do a stream tomorrow. No guarantees, but we'll refine some of this and make this a little bit more stable. We'll also add some, we'll look into like maybe adding some testing or something like that in here as well. So I'm looking here. Looks like we need to sticky these as well. As you can see here, when the width changes, the actual Pixi canvas doesn't resize. So yeah, these are like small bugs. We'll get these fixed up later on. I'm gonna go ahead and close this and get off the stream. That's my Minnesota goodbye. I'll catch you later. Thanks for coming by. Love you so much. Thanks for coming by. Bye. Peace. Oh, watch this animation, by the way. I'll talk more about what this animation stuff means later on, but go ahead and watch this again and come on back whenever you see the next stream. It's getting ready to go live. Peace.